Suppose I have a car just sitting there, sitting in a parking spot. Okay, and I write down that the acceleration is equal to F net over m. I'll leave it in one dimension since we'll just talk about a horizontal component, horizontal motion here. The car's just sitting there. Well, it's not moving, therefore the acceleration is 0, therefore the net force must be 0. Okay, that seems reasonable. I'm comfortable with that. But what about this case? I've just gotten into the car. Okay, and now I'm driving down the road at constant speed. Okay, I'm driving down the road at constant speed. Well, what does this say? Are there net forces acting on that car? Well, according to Newton's second law, if I'm traveling at constant speed, the acceleration is still 0, which means the net force is still 0. This one's not as intuitive. We want to think, well, I've got to press on the gas. There's got to be a force to make it go forward. Well, that's because there's also frictional forces pulling backwards that we have to overcome. But if we are going only at constant speed, that means the force pulling us forward must be equal to the force pulling us backward, such that F net equals 0. Okay. This one catches us often by unawares, where a part of an object, any object that's moving at constant speed, also has no net force. That sometimes comes into play with the idea of like the force of a throw. Like if I throw a ball, okay, well clearly the ball was in my hand and I brought my arm forward, and during that process of bringing my arm forward right before release, I accelerated the ball. There was definitely a force which caused an acceleration. But once it leaves my hand, the ball moves forward at constant speed because there is no contact now. Though gravity is going to pull it down, make it speed up downward, the motion straight ahead is constant speed because there's no force, no acceleration. And so something can be moving and have no net force as long as there's no acceleration. So yes, the case of not moving, v equals 0, is a case of no acceleration, but v constant is also a case of no acceleration. This is applying Newton's second law, and we often call this case Newton's first law. So this is often called the first law because it's a fairly basic situation of, in the absence of a force, an object will travel without any acceleration. It can either be at rest and remain at rest, or it can move and not speed up, slow down, or change direction. That is the first law.